Dear students, welcome back to our lessons. Today we're going to have our last lesson on statistics. Remember, we were doing statistics. And today I'm going to speak about the histogram. The objective for this lesson is going to be to learn how to draw and interpret a histogram. How to draw and interpret a histogram. That is our lesson for today. That is our objective. I'm going to start immediately by explaining what is a histogram and when we need to draw a histogram. I have already explained this in the previous lessons. So for those of you who have seen our videos, they know what I'm going to say. So when do we draw a histogram and what is a histogram? First of all, we need to draw a histogram when our data is continuous. Meaning we're dealing with mainly with length, with mass, with time, and all those variables which can be subdivided into an infinite number of times. So our data has to be continuous when we're drawing a histogram, and very important, a histogram, it is a bar chart whose bars will touch each other since they are continuous. Alright, since they are continuous. So difference between the bar graph and this one is that in the bar graph we had discrete data, the bars were separate from each other. This time the data is continuous, so the bars have to touch each other. So let me explain. Let's say that we had a survey. We made a survey, we surveyed some people about their height, and we got the following data. So height of person in meters, h in meters, and frequency, the number of people. So that's going to be our table. Height with frequency. And shortest height was 120. And we grouped the people in groups of 10 centimeters, from 120 to 130, from 130 to 140, from 140 to 150, from 150 to 160, from 160 to 170, and from 170 to 180. We had 4 people, we had 6 people, we had 10, we had 15 people, we had 8 people, and we had 5 people. Alright, so that is our data. So there were 4 people whose height lied between 120 and 130 centimeters. Note that 130 is included. There is this symbol, alright, very important symbol showing that it is included, okay, and the 120 is not included. Even here the 140 is included, alright, here the 150 is included, here the 160, the 170, the 180, pay attention for that, okay. So, for example, if I had to measure the height of another person, and that will be 150 centimeters, the 150 centimeters lies in the range from 140 to 150, because here 150 is included. Here it is slightly greater than. Okay, remember that to read the inequality, if I consider, for example, this inequality here, 140 to 150, that's read as height which is greater than 140 but less than or equal to 150. Now, to draw that histogram, we need to draw an axis. So I'm going to draw a grid first. Okay, so I have my grid. Frequency always on the y-axis. This time on the x-axis I'm going to have height in meters, centimeters. Okay, height in centimeters. So now frequency ranges from 0 to 15. So 0, 2, 4, 6, 8, 10, 12, 14, and 16. Now the height starts from 120. It doesn't start from 0. So what are we going to do? Our graph always starts from 0. So I'm going to do this symbol showing that I can cut from 0 to 120. And then I have to start at 120 and my scale should arrive at 180. In a histogram, I should have a scale on both axes. This is very important. Alright? This is very important. I should have a scale on both axes. In fact, this is one very big difference between a histogram and a bar graph. Alright, I have a scale on both axes. So 120, I have to arrive to 180. So I have 130, 140, 150, 160, 170, and 180. And then I need to draw the bars. Alright, the bars, as the bar graphs is very similar to the bar graph, so there's no difference there. So I have from 120 to 130, I should go up 4. From 130 to 140, I should go up 6. Now that the bars are overlapping each other, from 140 to 150, I have to go up 10. Then I have to go up 15. Then it's 8. And last one is 5. Okay, so as you can see, there is our histogram. Important, very important. We have a scale on both axes, right? A scale on the y-axis and the scale on the x-axis. And the bars are touching each other, okay, since it is a continuous set of data. In a continuous set of data, it's normal to have ranges. Okay, so that is a histogram. Okay, that's what defines a histogram. That's what makes it different from a bar graph. I can draw another example, or we can interpret one. Okay, so let's interpret one. So I have the following bar graph. Let me draw it. Now here we have a histogram. In this histogram, we're shown the number of donkeys which have a weight between 100 and 110 kilograms. There's a farm, they have some donkeys, and these donkeys vary in weight between 100 and 110 kilos. So, if I had to ask how many donkeys live in this farm, how many donkeys live in this farm? So all we need to do is to find the number of donkeys. So we had between 100 and 102 kilograms, we had 3 donkeys. Between 100 to 104, there were 7 donkeys. Then there were 9, there were 8, and there were 2. So adding this up, I get a value of 29. There are 29 donkeys. I can ask, so that was question number 1. Question number 2, what is the modal range of weight of donkeys? Remember when we made those tables? The modal range. So, the most common, the mode is the most common. The most common, there were 9 donkeys which weighed between 104 and 106 kilos. So, the modal weight is going to be between 104 and 106 kilograms. That is the modal weight. We can ask for the range. For example, what is the range of weights? The range is the largest value less the smallest value. So that's a range of 10 kilograms. We can also ask for the median weight. The median class. In fact, it's not just one weight, it's a class, because they are in classes of 2 kilograms from 100 to 102, and so on and so forth. Remember how we did this? It's n plus 1 on 2. N is the number of donkeys. We found out that to be 29. So it is the 15th donkey. And where does the 15th donkey lie? We start from 3. Plus 7 is 10. Still not 15. Plus 9 is 19. So yes, we have found the 15th one. It lies on the third bar. The third bar, which says that it is a weight which lies between 104 and 106 kilograms. Okay, so as you can see from a histogram, I can ask you questions which in other lessons we did when we found the mean, median, mode and range from a frequency table. Okay, so we can be asked to draw the histogram, we can be asked to interpret the histogram. Okay, this is the end of this topic. We'll discuss it in our live session. Hope you have understood. Have a nice day.